this video I'm going to go over exam number 2, set A. So let's get it started. The change of displacement is 0. What would be the potential energy of a spring? 0. All right, even if you put a ball over here on the top, what would be the potential energy on this ball, okay, if the displacement is 0? So the potential energy of this ball is of course 0. You have to have some displacement to have the potential energy, okay. So if I change the scenario, if I have spring compressed, this is a compressed spring, all right, and I put the same ball over here, all right. Now what happened? If my spring constant is change of spring, if the change of spring or displacement is 0.10 meter, then do I have any potential energy? A spring potential energy? Yes, of course I do. All right, let's find how much. So the potential energy is equal to half kx square. So potential energy is half, let's say k is 50 Newton over meter, and this is 0.1 meter square. So then potential energy due to spring is so this is 50 Newton over meter, this is 0.01 meter square. So meter square, meter goes to meter square once, so PE half times 50 is 25 Newton, and this is 0.01 meter. So then you have 0.25 Newton meter or joule, 0.25 joule. Yes, so spring potential, this one has this much, this one has this much spring potential. What can you do with this one? This is problem 51 from 2019 Reasons Physics, and this would be problem 52 and 53. All right, so these can become a kinetic energy. This potential energy can become kinetic energy. So kinetic energy is equal to potential energy. So half mv square is equal to potential energy is 0.25 joule. So mv square is 0.50 joule. So b square, so let's say mass of this red is 0.1 mass is 0.1 kilogram, 0.1 kilogram. So then 0.1 kilogram, and this is 0.50 joule. Put 0 over here, decimal cancel. So v squared is 5. You have kilogram. So 5 joule over kilogram. So you square root both sides. So then velocity is 2.2 meter per second. So this spring potential energy can become the velocity because it has some kinetic energy. Okay, next problem we're going to do 54. 54. The problem 54, we have to draw a parallel circuit. All right. So we have to draw a parallel circuit because the equivalence resistance is 5 ohms. All right, so whose combination give you 5 ohms? Well, this combination give you 5 ohms if R1 is 10 and if R2 is also 10, and then this is voltage. This is positive terminal, this is negative terminal. Why this one is going to give you 5 ohms? So 1 over R is equal to 1 over 10 plus 1 over 10. So 1 over R is equal to 10. So 2R is equal to 10. So R is equal to 5. So this is going to give you another way you can do the same thing is this. So this is R1 is equal to 10. This is R2 is equal to also 10. and this is of course positive terminal, negative terminal voltage. Okay, so that would be problem number 54. Now let's see problem 55. Problem 55 is, if I give you this distance versus time graph, and that is a diagonal line, what is the velocity versus time graph? Okay, this is super easy. This is the velocity versus time graph. These and these are the same steady. Why? Because this one has a velocity is constant. This one also velocity constant. This one acceleration is 0, this one is acceleration 0. So they are same way of telling the same story, different way of saying the same story, and that would be problem number. So this one is problem 55. Now we're going to do problem 56, and that is the Snell's law. N1 is N is air, so index of refraction for air is 1, N is X unknown, so a light moves from N1 to N2 with 25 degree. Okay, so what do we have to do? We have to find we have to measure this one. Okay, what would be the theta over here? So we take our protractor, so we're going to put the protractor like this. So I'm going to draw a protractor, so I'm going to draw a protractor. Okay, so now, all right, so let's try again. I'm going to draw a protractor, so let's draw a protractor, and let's draw like this. So this is a protractor, right? And if this one reads this one reads 50 degree, what is this one? This one has to be 40 degree, right? Okay, this one has to be 40 degree. So the answer would be 40 plus 40 degree plus 2, plus minus 2. Why plus minus 2? 40 is the measurement, and 2 is the error. If you write only 40 degree, that would be wrong. Why? Then you would be telling the people that your measurement is 100%. You can measure things with 100% precision, but no one on the earth can measure things with 100% precision. You can write 40 plus minus 1, or you can write 40 plus minus 0.5, or you can write 40 plus minus 0.1. All right, since it is degree, you always use the whole number. So 40 plus minus 1, that means you are telling people that you can measure things more precise than the other people. But the best way to go about it is 40 plus minus 2. All right, good. And now we're going to find 50, this is 56, 57, 58, we're going to find 57 and 58, we're going to find the x unknown. So what is n1? So n1 sine theta 1 is equal to n2 sine theta 2. n1 is unknown, so sine theta 1 is 25, n2 is 1 because it's air. Sine theta 2 is of course 40. So then x is sine 40 over sine 25. So x is 1.5. So this is 1.5. This is medium 1.5. So this is either crown glass or sodium chloride. But if they don't ask you, you don't have to provide that. They only ask you index of refraction. Index of refraction is 1.5. That's all they ask you, and that's all you have to write. What type of material they did not ask, so don't write. Okay, so that would be 56. Of a watermelon. Okay, you draw a watermelon. This is a watermelon. You draw a watermelon with 29 meter per second. Final velocity final. Okay, you draw it from height h. You draw it from height h. All right. What would be the h? Question is, What would be the h? So your final velocity is 29. I used to do it, I used to drop it on the head, so I used to make kids excited. I used to make children excited when they see that all the potential energy over here become kinetic energy over here. Then they used to get excited, and once they are excited, you can teach them anything. Okay, good. What do we need to find? We need to find the height. So we can say potential energy on the top is equal to kinetic energy on the bottom. So potential energy mgh is equal to half mv squared. What does that mean? That means you can cancel lots of things. So h is equal to 2g v squared, right? So h is equal to 29, 2 times 9.8. 29 is squared, don't forget that. So h is equal to 29 squared over 19.6. So let's say 600 divided by 20. All right, 600 divided by 20, so which is about 43 meters. So this h, you drop it from 43 above the ground so that it accumulate 29 meter per second velocity before it hit the ground and break. You can also solve it this way. Vf squared is equal to vi squared plus 280, and this one is 0, so your d would be 43 meter. So you get the same answer, so you have a preference. Next problem, 61, 62, a momentum problem. So there is a car, you call B, you call A, car A, moving with 4 meter per second to the east, and it is 100 grams. So it's probably a toy car. Collide with car B, which is at rest and which is 150 gram. This I would like to call it before, and this is I like to call collision. All right, car A collide with car B. So this one, what happened? The car A moves with 1.5 meter per second. So the car A lost some kinetic energy, and car B, we want to find the velocity of car B. Of course, we want to call it after. So momentum before is equal to momentum after. So m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. Okay, so this one is 0, right? Because this one is at rest. So m1, people usually make mistake. This is not SI unit, so make it SI unit. So 0.1 kilogram, and v1 is 4 is equal to m1 is 0.1, and v1, of course, now v1 is 1.5, but people usually make mistake. They don't see this move to the west, so put negative, and plus m2, people always make mistake. This is not SI unit, so 115 kilogram. So 0.15 at velocity. So you want to find this velocity after. So then 0.4 is equal to negative 0.15. You can put 0 over here. Is equal to 0.15. All right, so you add this 2, so what do you get? You add this 2, so you get 0.55, and you have 0.15. Decimal cancel. 15 goes to 60 4 times, so this has to be less than 4. So this car moves with 3.7 meter per second to the east, and that would be the solution to this problem, which is 1200 kilogram and moves with 25 meter per second. All right, this is a happy car. It has a momentum. What is the momentum? Momentum is mv. So momentum initial is mv initial. M is 1200 kilogram, v is 25. So the momentum is 30,000 kilogram meter per second. This is a happy car. All right, now all of a sudden the car driver see a man, Mr. Berry, is here on the road, crossing the road. So what would be the immediate reaction of the driver? The driver want to save Mr. Barry because driver doesn't want to kill anybody. If driver want to save Mr. Barry, at this point the driver velocity has to be 0, or kinetic energy has to be 0, or momentum has to be 0. All right. So momentum final has to be 0, right? Otherwise, then the driver won't be able to save the man. So what is it? Impulse. All right. The momentum is this. Impulse has to be what? Impulse has to be exactly this. All right. To save the driver, your impulse has to be 30,000. Okay, but opposite direction. If your momentum is 30,000 this direction, okay, and your impulse is 30,000 this direction, then what happened? The car stops. Kinetic energy is 0, and that's exactly what happened. So change in momentum is what we call impulse. Is momentum before momentum final minus momentum initial. So momentum final is 0. And momentum initial is 30,000. All right, so 30,000, negative 30,000 kilogram meter per second. Why negative? If it is positive, what happened? If it is positive, then that would mean is instead of hitting the brake, driver hitting the gas, so that the momentum would be double. Not 30,000 is going to be 60,000. So negative means you hitting the brake. That means the momentum would be 30,000 here, and momentum would be 0 here. This is change in momentum, which we call impulse. Very important. Of an object from 80 meter above the ground, okay, and is fall on the ground. If it happens, then I can make this one as my coordinate plane. So this is my coordinate, so I'm going to let this one is 0, 0. All right. If I do that, then my displacement versus time graph would be what? My displacement versus time would be, I need 2 points. The first point would be 0, 0, and the second point would be negative 80, 4. All right, so I am going to get something like that. This is the graph. Okay, now let's do the velocity versus time graph. Velocity versus time graph. Velocity versus time graph. So I'm going to basically need 2 points at least. So this is 0, 0. Okay, and this is negative 40, and this is 4. So I have this curve. All right. So how did I find negative 80? Oh, well, I found it by d is equal to VAT plus half AT square. How did I find negative 40? Well, VF is equal to VI plus AT, and that's how I find it. So A would be 10 and T would be up. All right, so Mr. Barry is on a bike trip, so T1 is 0 and D1 is 0. T final is 1.5, D final is 30 because the position function is 40/3 T square. All right, now we want to find the displacement versus time graph. Well, displacement versus time graph, we have it a parabola because this is 1.5 comma this one is 30. All right, now we're going to find the velocity versus time graph. Velocity versus time graph. So velocity versus time graph would be also 2 points. This is this is 1.5 hour, and this would be final velocity would be 40. Velocity versus time graph. Why final velocity would be 40? Let me show you quickly. The distance, let's find the distance. So distance would be what? D is equal to VIT plus half AT square. So D is 30, okay, because the total trip is 30. This is 0, so half AT is 1.5 square. So that means A is 26.7. All right, and the V is VI plus AT. So this is 0. So A is of course 26.7 and T is of course 1.5, and that gives us 40. Okay, very simple. Now we're going to do 68. All right, 68, you have home to work. If I go move home to work with 40 miles per hour, and the distance between home to work is 120 mile, and then you move from work to home with 60 mile per hour, then your DT graph would be, displacement versus time graph would be what? Well, you need to find the time. Okay, so find the time. Time is 120 divided by 40, which is 3 hours. Time is 120 divided by 60, which is 2. So total trip is 3 plus 2, 5. So 1, 2, 3, 4, 5. Total trip is 5. Okay, good. Now 5 hours, of course. So displacement would be, the home to work would be, it takes 3 hours. So this is home to work, and work to home would be 2 hours. Okay, so this is 3, and this would be 120. All right, very nice. We don't need to put that. Okay. All right, now we're going to do this. Make sure this one looks little. This one is look little shorter, because this takes only 2 hours. This takes only 2 hours. So this is shorter, 2 hours. So this is negative 60t, or just 60t, and this is 40t. Okay, good. Now we're going to do velocity versus time graph. Velocity versus time graph. Velocity versus time graph. Okay, so when we do velocity versus time graph, what do we do? Velocity is the blue, so velocity is blue, so 40, and then time, so then the red is negative, so negative. Okay, so this is 3, this is 5, so this is the red plus blue would be 0. Red plus blue would be displacement, and that would be 0. Okay, good. So displacement would be 0. Anyway, all right, now we're going to do 69. 69, convert this one to distance versus time and speed versus time. We have to convert this one to distance versus time. So we take the absolute value. If we take the absolute value, this one look like this. And if we take the absolute value of this one, this look like this. Okay, and everything else remains same. So this is 1.5, and this is negative, this is positive 80, this is 1.5, and this is, of course, 40, positive 40. Now we're going to find the distance under the curve. So the distance, or area under the curve. So area under the curve is distance. So now when we find the distance, what are we talking about? Find the distance is area, which is half BH. So area is half, B is 1.5, and H is 40. So area, which is distance, which is 30 mile. All right, now we're going to find this one. This is going to be, this is problem number, this one problem number 69, and this one 70, and this one is 71. 71, we want to take the distance versus time graph. So distance versus time. So we take the absolute value of this. We take the absolute value of this blue. What is the absolute value of this blue? Well, this is already positive, so absolute value of this one is the same. Now we're going to take the absolute value of this one, the red one. The red one is negative, so absolute value of red one is this. So the red one is 60t, and this one was also already positive, so it remains positive, 40t. So this is 3 and this is 5. All right, so no, this is 3, this is 5, and this is 120, this is 240. Okay. All right, now we're going to have to find this one, the speed versus time. So speed versus time would be, okay, so this is speed versus time. So now this one will remain like this. Why? Because this is already positive, so it doesn't change. It's the same thing. However, this one become positive. Okay, so this one become positive. All right, so this one become positive. So that means this is 60 and this is 40. This is 40 and this is 3 and this is 5. All right, now I'm going to go over the extra credit problem. So P of t is 40 over 3 t squared, and this is 0.1, this is say 0.2, this is say 0.3, this is 0.4, this is 0.5, this is 0.6, and this is 0.7. 0.1 is t1 0 d1 0. 0.7 P1 T7 is 1.5, D7 is 30. If you put 1.5 here, it gives you 30. Very nice. So T and D5 would be 29.2 and D6 would be 29.6. All right, now problem number 1. How can you find the average velocity? Which 2 point give you average velocity? This 2 point give you average velocity. Okay, so average velocity has to be d7 minus d1, t7 minus t1. So average velocity is 20 miles per hour. Which 2 will give you the instantaneous velocity? Okay, there are 2 ways you can find the instantaneous velocity. One is instantaneous velocity is d7 minus d6 and t7 minus t6. So d7 is 30 and d6 is 29.6 and 1.5 minus 1.49. Okay, and that gives you almost 40 miles per hour. What does that mean? If the distance between P1 to P7, all right, is getting 0, if the time between these two is approaching 0, all right, the time between these two is 1.5. The time between these two is less than 1.5, and time between these two is almost 0. Time between these two is almost 0. So delta t over here is almost 0. When that's happened, the velocity approaches to 40. Okay, because this velocity is almost 40. Okay, so there was the test number 2, set number 1, and tomorrow I'm going to go test number 2.